All right, so office hour questions. So good, there's lots of questions on here, which is great. So let's hear. I'm gonna try to go through the best of this. Who's gonna be my timekeeper? Just give me a thumbs up if you're gonna stop me when I hit a certain time.
Do you want a timekeeper, or is that what you're looking for?
Yeah.
Okay,
All right, Jessica's my timekeeper.
I'll keep the time, yes.
Okay, so in
Wait,
15
what time
minutes,
do you want me? Okay, yeah.
If I'm still going in 15 minutes, just let me know so I can I don't go on forever. Okay, cool. All right, so let's see here. So there's lots of questions, so we'll just kind of go right through them. So what are best practices for utilizing lat-long data zip code? Okay, so this is great. Best practices. One thing to note is that because we're talking about sales prices of the house, right? You probably don't just want to know, knowing the specific location, like the lat longitude is probably not very useful information by itself, right? Hopefully that makes sense. If you're in a linear regression, right, we have a continuous variable. If you have as you increase the longitude, right, it doesn't automatically increase the price of the house or decrease the price of the house, right? It's obviously more complicated than that. So same thing, even with zip code, the numbers in the zip code itself, these are probably going to be closer to a categorical information. And so I would say probably for this particular project, right, is you probably have heard location, 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 right, for real estate and stuff like this, is that this probably is important information, but I would first of all say for longitude, latitude, you probably want to feed this in as a straight, just raw information, right? You just want to have the longitude, latitude as separate features or as features of themselves. They probably are tied together in some way. And then even zip code again being just a number, right? So you wouldn't want this postal code just to be a feature by itself. You would probably, if you wanted to do zip code, you could do this with a category, right? That's one hot encoding. Now I will tell you is that you could do it this way. And in fact, I would suggest, if you just want to try a simple one, go ahead and try doing categorical zip code. But this information, you can try this out, play around with it. It's probably not enough. You'll probably find that it's either going to be really difficult to interpret or it's not going to do a great job in doing predictions. So does anyone have an idea what you could do beyond just the zip code and longitude, latitude, at least using this information, but doing something? Yeah.
I know that I went and I tried GeoPy to get the actual neighborhoods that these were in. The only thing with GeoPy is that you're allowed a certain rate of information that you're allowed to download, and after that, it just, it stops. So you have to then put a rate limiting. There's a rate limiting setting that you have to set, but then it takes way too long. So yeah, so that's what we're trying to do that for the Kaggle, but I abandoned it. Just too much trouble.
Yeah. So this is where oh, go ahead.
I was saying, yeah, I tried that as well, and with the API, you kept getting stuck. But there's a reverse geocoder library that's quite good. It just returns. It doesn't give a full address, but gives a neighborhood. And with that, you can at least sort of get a sense of where things are.
Which one is that?
It's called reverse geocoder.
I'll try that.
And I thought instead of having it as neighborhoods, you could sort of just define tiers like top neighborhoods, medium, and low, or have I know 5 or something, because each one is too many, but it maybe is still useful.
Yeah, no, perfect. I think that's a really great way. Use whatever you can. Some APIs are going to make more sense for other things. This is kind of building up your features, and I think the right way to kind of do this is neighborhoods or something that's a little more coarse. That's going to be I think this is going to be too exact, where I think you're going to find patterns in there that that might not really be relevant, and where really we think about what do you talk about when locations, about neighborhoods and areas and stuff like this. And I've seen some people do some really interesting ways of defining these different how to use this information. So that's the way you should think of this, is that these are probably by themselves not sufficient enough to do good predictions, but you can use that to build up new features, right? That could be relevant, like neighborhoods. And I won't give away too much. I want you guys to be as creative as possible. So there's other things you could probably do with this stuff. Yeah, just
What about some type of like cluster analysis or looking at like nearest neighbor home prices? Because I know in real estate, that's actually a big thing. Like, oh, homes in this neighborhood go for, and that's how they can gauge it. So like, what about something like that?
Yeah, see, this is where like I think like that is an important part. And for this project, I would say just because we're focusing mostly on linear regression, I would save some of that stuff if you want to try it out. If you have extra time, right? Like try out this other stuff first, and then see if you can add on top of this, or you can talk about it as future work. Just because I think it's a really like if we had like a month, I would say yeah, like go for it. Like try it out, see what happens. Play around with it, see what you can do. But just considering the nature of it being 2 weeks and stuff like that too, think of that as a secondary. Like okay, let me check it out if I have time. And this is honestly like close to real life too. Like if you can do a great job of making predictions without this information, maybe this information does have some pretty good stuff, but if you can do everything else, like, and do a pretty good job of prediction, like, why would you wait? Let's just pretend like you have like a month, and you spend 2 weeks on this, but it turns out you could have spent those 2 weeks and make a pretty good prediction without using that information. You're kind of like cost benefit analysis, like, oh, like we can come back to this, but we have a good prediction already. So kind of do that kind of analysis too, or like your own like meta-analysis right on yourself, being like, oh, how much time do I have? Do I have time to export it? But if you're interested, right, especially even after this project's done, you could definitely come back to it and try to apply those things and for your own education, right? And you can always, these projects, even though they're project assessments, they're really portfolio projects for you to show off to other people, right? You can talk about these things in like an interview. So you can always add more. Cool. All right. Cool. So I'll move on to this, and we can maybe talk more about this, or like Nadine shared, that API that works, like see what works and share with each other. There's no shame in like this project. There's no reason you can't talk to each other, even if you're doing it on your own. All right, so let's go to the next question. Would it be a good idea to use the date of sale for the King County housing data set to adjust for inflation, or do we need to, do we not need to, because the relationship between date and price will be considered automatic by the model? Yeah, this is going to be a good exploration part. I'm not going to tell you the answer of that specifically, right? Is that if you do see like sales going from 1950s to 2000, yeah, inflation is probably going to have an effect on this, right? But if all your dates like are within the past year, like you probably don't have to worry too much about inflation unless there was a big event that had happened that you know of. Let's say financial crisis in 2008, or let's say for right now, like with COVID-19 and stuff like that, if you're looking at recent prices, they probably, I'm guessing, I don't know if the model said, I'm pretty sure like, some models predicted like, oh, these houses are selling for lower values or whatever. So there's going to be a dip in that. So those are kind of things that you should consider. But the best answer to this is really looking at the data and seeing, does it make sense for inflation or not?
For real estate, probably the rate of increase is more important.
I'm sorry.
The rate of increase for the price of a house.
Right. Yeah. So like, this is where you have to know domain knowledge, right? And explore and see if it's going to be relevant and stuff. But I will say date of sale, right? Again, this might be partly for inflation, but you could also pull out other information that might be relevant in here. I would say right now, you can explore it, but it's one of those extra things. I would say maybe stay away from time series analysis, just because we haven't gone into any of that. And you have a lot on your plate already for this first project with linear regression. So you can do those things, but I would say maybe don't dive too deep into those things. Okay. Cool. All right. Cool. I'll move on to the next one. So if the relationship between two features appears to be polynomial, should one be removed to prevent multicollinearity, or multicollinearity not be an issue since the relationship appears to be polynomial? Oh, that's a good question. So remember, multicollinearity basically means that these are correlated with each other, like features are correlated with each other. Now, this can be kind of tricky, is that I'm going to say this is polynomial, but I'm going to say like, let's say like interacting features, which is kind of like polynomial features. You might see multicollinearity between two features, like they're correlated with each other, but then you find out by adding a polynomial term, an interaction term, those terms actually do really well. Like they are low p-values, right, when they're included in your model, and actually do a pretty decent job of like making a prediction or adding to your target. So in that case, then first of all, polynomial interaction features are different from multicollinearity, right? Is that correlation basically saying, or multicollinearity is saying that they are collinear, they are related with each other. They are basically encoding for one for the other. But you might have an interaction term that basically is more than the sum of their parts, if that makes sense. So in multicollinearity, if we have something like x1 plus x2 and x1, x2 are collinear with each other, you might have issues in there, right? Where basically you're double counting and stuff. And the best option is to drop it. But let's say you try x1, x2, and then you also have x1 times x2, right? Essentially 3 different features. And you find x1, x2 has a very low p-value. In that case, you're like, whoa, it actually makes sense to keep these as an interacting term. And in the case of interacting terms, I don't think we really talked about a lot of detail. In general, good practice is that if you find your interacting term is a good, candidate for a feature, right? So it's low p-value, it's related to the target variable, right? Then you should keep the x1, x2 by themselves independent as well. So if you find the interacting term being an important aspect, then you should be keeping those other 2 parts that are independent from the interacting term. Does that make sense? Okay, and the idea there is because you found that there are significant, even if these x1, x2 are actually in low p, like a high p-value, so they're actually technically like, I was like, oh, the model says, oh, we can't show there's a statistical significance that they actually add to the target, but this interacting term does, you really should be keeping these 2. Okay, cool. Yeah, hopefully that kind of answers what's going on here. But yeah, keep an eye out for multicollinearity. But one thing to check out is trying out, interaction terms. But a real solution is either dropping it or creating a new feature, which is what that interaction term really is. Okay, cool. And note that if you have polynomial terms, those obviously will be correlated with your, non-polynomial terms. If you have x1 and x1 squared, obviously x1 and x2, or sorry, x1 and x1 squared are going to be correlated in some fashion. And I think I saw someone unmute.
That was me.
So
I just want to make sure. Okay, so if 2 features appear to be related, like polynomially, I don't know how you'd say that, keep both or put an interaction in?
Right, so you're saying if you have like x1 and x2 and they are, like they have collinearity with them, is that?
They look to be related. Like if I graph the 2 features together, it looks polynomial.
Right. So this is where you might have to decide on what kind of model you're making. So if you are making a model that has more complex features like polynomial terms, interacting terms, look at those interacting terms and seeing, are those significant? And if those are significant, right, low p-value, then you want to keep that, original non-interacting term. If you're making like iterations of your model and you try just a simple one and you find that like your p-value is really low, or sorry, really high for like this, collinearity, are you seeing that these are correlated with each other and you see that the p-value is really high, you should probably drop one of those. And usually those things, if you look at them, you can probably see where the dependence comes from. Like why are they correlated with each other? But not always. Make sense?
Yeah, it does.
Okay.
Cool, thank you.
No problem. All right, so let's see here. We have a few more questions. So even if we don't go through all of them, we'll definitely go through them eventually. So is it best to have all library imports at the start or add them in sections? I personally like to put them at the start if I'm like reformatting my notebook, just because it's easy for me to find where all the imports are. I have seen people, and I'll even do it sometimes, have the imports like in the middle of it, but mostly I'll do that if they're like optional. But the thing is, like, let's say, for example, I'm writing my notebook and I skip over that part, because I'm like, oh, I don't need to do this section for whatever reason, but there's an import in there, and then I use that import later on. Then it's like I have to go dig around in the notebook and figure out where it is. So I'd say my suggestion is put them all at the beginning if possible. Okay, cool. All right, let's see here. What else we got? What would you do for a baseline model before one hot encoding? Oh, would you do a baseline model before or after one hot encoding? Yeah, so there's 2 questions addressing multicollinearity too. So I would say is that if you are doing exploration, don't one hot encode first. Do your exploration and then one hot encode, just because if you one hot encode with, like, let's say something has, let's say you have 20 features and then one of your features is categorical and that category has like 20 different categories. Well, the problem is now is that instead of having 20 features to explore, you now have like 40 features to explore, and half of them are just from one category. So it's usually a good idea just to explore off of before one hot encoding. But your model, you should be if you need a one hot encode, you should be one hot encoding before modeling, right? Because the one hot encoding basically is preventing the idea if you have categorical labels where it's like, you know, let's say you had like red, blue, green for like the color of your house, and you had labels as 1, 2, 3. Well, that's probably not a good idea to keep it that way, because now your model's going to think 1, 2, and 3 are going to be related with each other, right? So you won't have to one hot encode, because that's going to prevent your model treating it as like a continuous variable instead of treating it more of a categorical variable. Okay. And then doing the baseline model, I would say, yeah, you might not, the multicollinearity thing, you might try it with and without those collinear parts, like just to see what happens. So that's like your p-value, right? So I'd say in some ways, yes and no, model it. And then you can also model it with it dropped out. So just play around with it, I would say. And then I think I saw, Jessica, go ahead.
In 15 minutes.
Oh, thanks.
Yep.
All right, cool. That was it, right? The 15 minutes mark. Okay, cool. So let's hear. I just want to, maybe I'll answer this last one, and I'm just kind of quickly looking. So let's just make a space here. I just want to answer one last one, and then we'll go into Kaggle stuff. To use log transform price to continue. Yeah, we'll talk about this for next time. What are we supposed to display the regression analysis part of the technical audience? I think I talked about this a little bit, but we'll maybe review that later. How do you present the good predictions models? We'll talk about that. All right, so I'll talk about this last one right here. Would I split my data before, after cleaning and scrubbing it before ask? No, I'm gonna wait until next time too, because this is a lot more detail. So yeah, we're just gonna stop it here. Like stop the questions from here, and then we'll talk about this next time. Sound good? If these are like burning questions, you're like, I need to know because I'm working on this right now, ask them on Slack, right? Or, you know, if we have one-on-ones, you can always ask them one-on-ones, but ask on Slack because I'm pretty sure other people would like to know the answers to these things too. Cool. All right, so just know this doc's still open, so you can always add more stuff.